So here's an example where we're asked to solve a quadratic, but it's in standard form. The example I did in class was vertex form, and in that case we were allowed to use reverse Pemdas, like undo what was done by doing the opposite. Here we can't do that, but we do know how to convert this to vertex form. I'm going to do this with all method and no picture. If you're not there yet, you might want to look at the other video that I posted that reviews how to do completing the square and try to rely on the picture mentally instead of drawing it. I'm also not color coding stuff. So to put this in vertex form, we're just going to look at this one side of the equation, because that's where there's stuff to do. And we're going to focus on those first two terms. And I know that I'm going to take half of this linear term and square it. So half of 8 is 4. That's going to be 16. I'll add that 16. I'll subtract that 16. And then I still have that plus 12 to deal with. And then this portion I know creates a square where each side is x minus 4. So this portion becomes x minus 4 squared. And then these guys combine to make a negative 4. So saying what I had, this expression is literally the exact same thing as this expression. But now I have a situation where there's just one x as opposed to an x squared and an x, and I can solve this for 0. I like to describe this as using Pemdas in reverse. Anytime we solve, we're doing order of operations backwards. So we're looking at this side of the equation, and we're asking ourselves, all this stuff in the parentheses, I can't even worry about that until we get up here to p, and we got to start down here. So outside of the parentheses, if there's anything to add or subtract, I'm going to do that first. So of course there's a negative 4 here. I want to get rid of that by adding 4 to both sides. These would cancel. Left side would be left with this x minus 4 quantity squared. 0 plus 4 makes 4. I've taken care of that. I'm going to move up the ladder. I'm going to look still at this side of the equation where the x is. I'm going to say to myself, is there anything to multiply or divide? There's not. Now to get rid of the exponent, the squared, the opposite of squaring is square rooting. And what we saw in class is there's a couple things we can square to get positive 4. So when I square root this, it's definitely true that maybe I squared 2 to get 4. That's possible. Or maybe I squared negative 2 to get 4. Could have been either one. Two different things that might have worked. So when I square root this, not only is it the case that x minus 4 could equal 2, but it could also be the case that x minus 4 equals negative 2. I have to consider both possibilities. So if I add 4 to both sides here, we get x equals to 6. And if I add 4 to both sides here, we get x equal to 2. These are both going to be valid answers. Now if you wanted to check your work on this, you could graph the original problem, and you will see that when x equals 6, y equals 0, and when x equals 2, y equals 0. So it's going to work that way as well. Hope that helps.